Well, hello there. Today's video is going to be about the building blocks of geometry, the essential things that we need to know in order to get into really the meat of geometry. And those are points, lines, and planes, among other things. So our topic, points, lines, and planes. Our essential question is, what are the building blocks of geometry and what is an undefined term? So, if at any point you feel like I'm going too fast, feel free to pause or rewind. But let's go ahead and dive in here. So what is geometry? Geometry is a branch of mathematics that studies the distance, the shape, the size, and the relative position of things. We're going to be dealing with distance, shape, size, and position of different figures. And while there are many different types of geometry, the main one that we will be learning about is called Euclidean geometry. And it is named that after an ancient mathematician named Euclid. You can see the word Euclid in there, Euclidean. And it's named after Euclid because he's known as the father of geometry, because he went way back in the day and proved all of these geometric facts that we're going to come to learn. And what we're going to be kind of doing here is taking it one step at a time, kind of following the path of Euclid. We're going to be starting with the very basic things that he started off with, and then we're going to slowly learn more and more and more by proving these different facts true, just like he did back in the day. Now, if we're going to actually be able to prove that anything is true, we got to know how to do that. And there's multiple ways of proving things to be true. There's kind of three different things that we're going to be dealing with here. One is called a conjecture. Conjecture. And what a conjecture is it's something that might be true, but it hasn't been proven to be true yet. Some of you guys are probably familiar with the term hypothesis. A conjecture is like a hypothesis. It's something that might be true, but we still got to test and make sure that it is before we go any further with it. Next up is what's called a postulate. It's kind of a fun word, postulate. A postulate is something that we're just going to assume to be true, but we haven't proven it yet. And there were a few postulates that Euclid started off with that he just assumed were true, and he used those to kind of build up to bigger things. And then lastly, we have an actual theorem. A theorem is something that has actually been proven to be true. So we've got conjectures that we test to be true. We've got postulates that we just assume to be true. And then we got theorems that are going to be actual facts that are 100% proven to be true. So what are we actually going to be starting off with? What can we actually use to start building up to these bigger shapes? We are going to be starting off with the smallest things imaginable. These are called our undefined terms. And they're not called undefined terms because we don't have an actual definition for them. We call them undefined terms because they cannot actually be measured. These things are either too small or too big to be measured. And we have three of them. So three undefined terms here that we'll look at are the point, the line, and the plane. So a point is just a location of something. It has no length, width, or depth. It is represented by a dot. So this is what we would expect to see anytime we see a point. And you're going to notice that I put that capital letter next to it because that's how we name it. So in that picture there, that would be called point A. It's just a location there. I know that we represent it with that dot, and I might be able to take a ruler and actually measure that dot, but that dot's a representation. It's not the actual point. Next up, we have the line. A line is a one-dimensional object that extends in both directions without stopping. It has no thickness. So here would be a representation of a line. Those arrows on the end represent the fact that it's going to keep going and going and going and going and going forever. We name it using 2 points and a line picture above it. So I need to have 2 points on here. I'm going to represent those with those dots like we just saw. And I need to put those capital letters next to the dots to represent the names of those points. And so this would be called line AB. And to name it, put those little arrows above it. Now I could have called it line BA as well. You can switch those around. It doesn't matter with a line. But you're going to notice that there's another thing after named using 2 points and a line picture above. It says, or we can name it using a lower cursive letter or a lower script letter. So sometimes you might see like a lowercase L floating off to the side there, a lowercase cursive L. And that would be another way of naming our line. So those would be 2 different ways of naming the line. And then lastly, we have the plane. A plane is a 2-dimensional object that extends in 4 directions, never stopping. So a plane, we usually represent it kind of like this. It's like a giant infinite piece of paper, or a giant infinite table. It's a big surface. And we use it, or we name it using a capital cursive letter. So like you might see a big P, a cursive looking P in the corner there. So that'd be plane P. Or you can name it if you have 3 what we call non-collinear points. And we'll see that word later on. But that just means that they couldn't all be on the same line. So one way of naming this would be plane P, or we could name it plane ABC by using those points. Now, once again, notice that P doesn't have a dot. There is no point P. If there's a big cursive letter, then that's just the name of the plane. I could also shuffle the 3 points around. I could name it plane BAC if I wanted to, or CBA. The order of those letters doesn't matter if you're using the actual points. Now, just to reiterate something before we move on here, those are called undefined terms because they can't be measured, right? A point doesn't have any length, width, or depth. We can't take a ruler and measure it. A line is infinitely long. Those arrows mean that it keeps going, so you can't measure that. There's no official length of the line. And a plane goes infinitely in all 4 directions. So there's no arrows on the plane, but a plane's going to keep going that way, and that way, and that way, and that way. It's going to keep going in all 4 directions, like we wrote down there. We just can't put arrows on actual sides. So we just got to trust that it's going to keep going. So those are undefined terms because they can't be measured. So down below, let's practice naming these things. It says, name the following using correct notation. Well, in that first one, that's just a dot there. That is point A. And we name the point just by putting the capital letter. Number 2, we've got a line. So how do we name that thing? We could name it line CB. You got to put that line symbol above it. We could name it line BC. We can flip those around. It doesn't matter. Or we could just call it line M because we have the cursive letter over there. Once again, there is no point M. And we don't need to put the line symbol above it if we're using the cursive name for it. For number 3, we got a plane. We can, of course, name it plane P because we got the big capital cursive letter over there. Or we could name it DEF if we wanted to. Or we could name it FED. There's a bunch of different ways we could name it. Let me put some commas there because those are different ways of naming it. I could shuffle those letters around a few different ways too. I could do DFE, I could do FDE, I could do EFD, right? A bunch of different ways of naming that plane. And then lastly, for number 4, it looks like we got another line again. So I could name it, well, this is kind of weird because I've got 3 points on there. If you have more than 2 points on your line, you can just choose any 2 to name it. So like I could name this thing GI. As long as I put the line symbol above it, I could name it IH. Right, that would work. A lot of different ways I could name this thing, or of course I could name it line Q there. That would work as well. Remember, you don't need to put the line symbol above it if you're using the cursive way of naming it. Okay, so we got our undefined terms. Those are going to be the things that we use to build out our bigger, badder shapes as we move forward. Okay, so let's open that little book up, and on the inside left side, we should have this guy. So we've seen our undefined terms. Now let's look at our defined terms. Defined terms are terms that can be measured in one way or another. First up, we have the ray. A ray begins at 1 point and extends in one direction without stopping. So we have one endpoint, so that means that we can measure that, right? We know where it starts. And then it's going to go off in one direction infinitely. In order to name this thing, we do need 2 points. So let's say that's A. We know where it starts. It starts at A, and then it's going to head off in this direction. So I can put a B over there. So this would be ray AB, and we need to put the little ray picture above it. You cannot flip the order on these ones because that first letter needs to be the origin of it. The first letter's got to be where it starts. Second letter is just the direction it's going. Next we have the line segment. A line segment is a piece of a line, but this thing stops at 2 endpoints. So no arrows on this one. It just goes from one point to the other. Line segments are going to pop up all over the place in this class. They're going to be the main thing that we use to build out our bigger shapes. To name this thing, we do need 2 points and the segment picture above. So this could be segment CD, or since it's stopping at both ends, we can flip it around. It could be segment DC also. Lastly, we have an angle. An angle, another crucial component of this class, is an object created by 2 rays that share a common endpoint. So imagine I've got a ray going this way, and then I've got a ray going this way. That is how we make our angle. Angles can be named a lot of different ways. We can name it using the vertex. So the vertex is going to be the middle letter there. So that could be angle B. Or all 3 points that are used to make the angle, right? We're going to need 2 points on either end here to help name it. So let me put A, B, and C. So I could name this thing angle ABC. Notice that the vertex here has to be in the middle if we're using the three-letter method. And then we could also name it using a number written within the angle. So like if there's a 1 in there, we could also call this thing angle 1. So those are the 3 different ways we can name an angle. There's not always going to be a number in there, but if there is, you can name it that way. Notice all of them require the angle symbol in front of it. So angle B, angle 1, or angle ABC. Okay, so let's try to put some stuff down here. Number 1, looks like we've got a ray, and that would be ray ST. Notice I got to put the S first because that's the side that ends. That's the end point. Next up, we've got a segment. This could be segment UV or segment VU. Then we got this angle, and remember, there's a lot of different ways we can name the angle. So I can name this thing angle XYZ, because Y is the vertex, so it's got to go in the middle. Or I could flip that around. I could name it angle ZYX. That works. Or I could just call it angle Y. I could just use the vertex. Or I could name it angle 1. A lot of different ways we can name that one. And then we got another ray. Remember, to name a ray, we only need 2 letters. So I got to start with O, right? O is the beginning of that ray. And then I could put M, because it starts at O and goes towards M, so I could name it like that. Or, since it's an infinite thing, I could name it ON, because N is still the right direction that it's traveling in. You do not need to put 3 letters to name a ray, or a line, or a segment. All of those just require 2 letters. Never put 3. 3 capital letters are reserved for naming planes. Okay, so some more words. I know we got a lot of words in this video here. Collinear. Collinear is just 3 or more points on the same line. 3 or more points on the same line. So a picture for that could look something like this. If I got all 3 of those points, let's just call it D, E, F. D, E, and F would be collinear. Now, if they're talking about just 2 points, 2 points are always collinear because you can always draw a line through 2 points. So really, if they're talking about collinear, you should really be checking if 3 or more, because not all 3 points are always going to be a line. There's no way that you can draw a line through any 3 points. Got to be a special group of 3 points. Any 2 points, you can draw a line through it. Coplanar. Coplanar are just going to be objects, so this could be points, this could be lines, rays, angles that are on the same plane. Any 3 points are coplanar and determine a plane. So any 3 points, you can always make a plane through it. So a picture illustrating that. If I've got a plane here, and maybe I've got all 4 of these points. All 4 of those points are going to be coplanar because they're all sitting on the same plane. Then lastly, we got some opposite rays. Opposite rays are rays that share a common endpoint and extend in opposite directions. So if I've got one ray going this way to the left, so maybe this is ray AB, and then I've got another ray going to the right, also starting at A, AC. So AB and AC would be opposite rays because AB is going to the left, AC is going to the right. So those are considered to be opposite rays because they're going in opposite directions, right? They combine to form a straight line. Okay, so let's use that new vocabulary here and try to identify some of the stuff on our diagram here. What do we got here? 3 collinear points. So do we see 3 points that are all on the same line? I do. A, B, and C are all sitting on the same line, so we can say that they are collinear. Notice I don't include L, because L is not an actual point. L is just a name of the line that all 3 of those points are sitting on. 4 coplanar points, 4 points that are all on that plane. That could be A, B, C, and D. Notice that F is floating above that plane. It's not on it, so I couldn't use F. And I can't use R because R is not a point either. R is the name of the plane. Same with L, right? L is the name of the line. L is not an actual point. And then lastly, our opposite rays. If I look closely here, I've got one ray going to the left there, one ray going to the right here. So those would be my opposite rays. That would be ray BA and ray BC. Sometimes people want to say it's ray AB and ray BC. AB would be going the other direction. Ray AB would be starting at A and going this way. That's going the same direction as BC, so those are not opposite rays. Okay, let me do a little more color coding so that I know what I'm talking about later on. Okay, a lot of words. So let's get some practice in here. Let's take a look at some diagrams and try to answer some stuff. So let's look at this diagram here for example 1. It says name a line and a segment using the same points. Okay, so what about line HI? So line HI would be that entire line with the arrows included. And then I could just talk about segment HI too. Right? Segment HI would just be the part that's going from H to I. So just to kind of illustrate here, this entire thing here is line HI. And then segment HI would just be going from here to there. So there is a difference there, but I'm using the same 2 points. So by changing the symbol, I can change what I'm actually talking about. Name 3 non-collinear points. So what about H, G, and K? Those 3 points are not all on the same line, so those would be non-collinear. Name the plane in 4 different ways. So we can see the big plane there. Let's try to name that thing in a couple different ways. So one easy way, I could name it plane S, because S is the big cursive letter over in the corner there that doesn't have a dot next to it. So that is one way of naming that plane. Now the other way of naming a plane is by using 3 non-collinear points that are on the plane. So I could do HGK like I was just talking about on the last question. Those are 3 points that are on the plane that are not collinear. Maybe I want to do IKS. Nope, can't do S because that's not a point, right? So we can't include S, so what about I, K, and G? Those are 3 points that are non-collinear that are on the plane. And then let's just shuffle those letters around a little bit more. I could do, what about HGI? Those are 3 points that are all on the plane. But there's something wrong with that because HG and I are collinear, and if you remember, I got to use non-collinear points to name this thing. So what about HKG? Same points that I used for HGK, but I shuffled them around, and that's okay. So that's 4 different ways of naming that plane. And then D says name the point where the 2 lines intersect. So the 2 lines are HI and FJ. So FJ is this line here. So where did those cross? Well, they cross right at G. So that'd be the point where they cross. All right, example 2. We've got to follow some instructions here. Draw a plane and label it plane H. Okay. Draw a big plane here. I'm going to put my attempt to make a cursive H over there in the corner. Not going to put a dot there because if I'm naming the plane with just a single letter, that's got to be the fancy letter. Then it says draw 2 points on plane H and label them as R and W. Okay. R and W. Okay. Draw a line segment through points R and W. Okay. No arrows there because it just says line segment. And then D says draw a ray on plane H and label it with an endpoint K going through S. So draw a ray. So that's got an endpoint and an arrow. It says endpoint K and it goes through S. So that'd be one way of illustrating all the things that they asked us to do. Example 3, name the vertical plane in 2 different ways. Okay, so the vertical plane, the one going up and down, that is this guy. Okay, so name it 2 different ways. Well, one way would be A. right? A is the fancy letter in the corner with no dot, so that's the name of it. Or I could use 3 non-collinear points that are on that plane. So it looks like I see 4 different points that are on there. G, D, C, and E are all on that plane. So I just got to pick 3 of them and stick them together. So how about G, D, C? Those are all 3 points that are on there, and G, D, and C are not all on the same line, so that's a valid way of naming it. I could also throw E in there. I could do like GEC or something like that. That would work. Next one says name the horizontal plane in 2 different ways. So horizontal plane is this guy. Easy way of naming that is by using the capital letter in the corner, B. And then I need to take 3 non-collinear points, stick them together. I only see 3 points that are actually on this plane, D, C, and F. So let's just stick those together, and we're good. I could shuffle that around too. I could do F, D, C, C, F, D, anything like that. Name 4 coplanar points. So 4 points that are on the same plane. Looks like it's got to be from plane A, because A is the only one that has 4 points that are all on the same plane. So the 4 points that are on that plane would be G, C, D, and E. Notice I put some commas in between there because I don't want to jam them together, because then I'd be talking about something different. And then name the intersection of the 2 planes. So where do those 2 planes cross? Or another way of thinking about it is, what do they have in common? What do those 2 planes both have? Well, the only thing that's on both of those planes is D and C. And what do DC make? Well, they make a line, right? Well, it looks like a line segment, but remember, planes are actually infinite. They extend infinitely. So our intersection is also infinite, so I need to put the arrows above there. So the intersection of those 2 planes is line DC. Okay. Example 4. We're almost there. Name the intersection of ABP and BCD. Okay, so ABP, that is this plane up here. Remember, when you take 3 points and stick them together, that's the name of the plane. So that is that plane. BCD, oops, get a different color here. BCD, that's this plane. So what do those 2 planes have in common? They both have A and they both have B. And just like the last question we saw, AB makes a line segment, but remember, these planes are really infinite. We just can't draw it that way. So I need to make my intersection infinite. All right, B says name the intersection of BO and PAB. Oops. BO. Oh, no, I'm sorry, PO. PO is this line. And PAB, that's just a different way of naming the first plane that we were looking at. PAB, ABP, those are the same thing. So where does my red line cross the plane? What do they have in common? Well, they both have point P in common. That line hits that plane right at P, so that would be the intersection. And then lastly, for C, it says, are A, B, and R coplanar? Why or why not? Now, this one's a little bit weirder. A, B, and R, are they coplanar? At first glance, it doesn't look like it. It doesn't look like A, B, and R are all on the same plane, and that's because they're not, kind of. They're not on any of the planes that we have drawn in right now. But let's open up our imaginations for a second here. And imagine the plane that goes from A, B, down to R, across that way, and back up. This kind of like slanted diagonal plane. It's like a ramp, right, going from RO up to AB. That plane does have A, B, and R all on it. So yes, they are coplanar, And that's because any 3 points are always coplanar. You can always make a plane through any 3 points. So I'm going to say any 3 points determine a plane. Even if it's not drawn in there, you can always make a plane through 3 points. And that is also written in your notes. Where was that? Oh, that was on coplanar. Any 3 points are coplanar and determine a plane, right? Okay, so we went through pretty fast there. Next up is your turn. So the little sheet of paper you got is going to be your practice for now. I will go ahead and pause the video, try all of these things, try to answer these questions based on that diagram, and then come back and hit play and check to see how you did. Okay, hopefully you actually listened and you paused it, and let's see how you did. Name 2 segments shown in the figure. You had a lot of segments. The first one that I just saw was HJ. Another one you could have done NJ. You could do NJ, right? There's a lot of different ones here. HJ, MJ, JK, LJ, ML, HK. A lot of different ways there. As long as you put the line segment symbol above it, and you didn't use X, Y, W, P, any of those ones. What is the intersection of plane P and line X? Line X, oops, don't want to do that. Line X is this line, and it's going through your plane, and it's intersecting it right at J, point J. Name 2 sets of 3 collinear points. H, J, and K are collinear, and then M, J, and L are collinear. Those would be your 2 sets of 3 collinear points. What are 2 other ways to name plane P? Maybe something like M, H, and J. Those would be 3 points that are on the plane but are not collinear. Or maybe you could have done something like K, J, L. That would have been another way. Just make sure you're not including N, because N's not on the plane. And make sure you're not using any of the ones that we said in number 3, because remember, they need to be non-collinear to name the plane. Name 5 coplanar points. So naming the 5 points that are all on that plane. We want M, we want H, we want J, we want K, we want L. Those are the 5 points that are all on that plane. Name a pair of opposite rays within point J. So maybe JH. Oops, that is not an H. JH goes to the left, and then JK goes to the right. So those would be some opposite rays there. You could have also done JM and JL. And then are points H, J, L, and N coplanar? Explain why or why not in complete sentences. I'm going to say no, they are not. And the reason is that N is not on plane P. N is floating above the plane, right? It's up here. So it is not actually officially part of that plane, so they are not coplanar. All right, hopefully you guys felt okay about that. Like I said, feel free to rewind and watch again on any part that you had a question over.